Data is everywhere. It's in the countless documents we interact with daily. Think about PDFs, reports, and research papers. These documents hold a wealth of knowledge, but unlocking it can be a challenge. We need a way to extract the key information and make it easily accessible. This is where AI steps in, offering powerful tools for data extraction and analysis. Tools like PyPDF2, PDF Plumber, and Tika are our allies in this endeavor. They help us to extract text and data from these documents, acting like digital excavators unearthing valuable artifacts. PyPDF2 is our trusty tool for basic PDF manipulation. PDF Plumber excels at extracting data from tables and forms, like a detective piecing together clues. Apache Tika, our versatile explorer, handles a wide range of document formats beyond PDFs. Imagine trying to understand a vast library of documents. It's overwhelming. We need a way to break down the information into manageable chunks. That's where segmentation comes in. We divide the extracted data into logical units, sentences, paragraphs, tables. This granular approach allows us to analyze the information with greater precision. Think of it like organizing the library. Each book is categorized and placed on the appropriate shelf. This organization makes it much easier to find the specific information we're looking for. Segmentation does the same thing for our data, preparing it for deeper analysis. We've extracted the data. Now, how do we make sense of it? How do we teach machines to understand the meaning behind the words? The answer lies in vector embeddings. Vector embeddings are like translating text into a language computers understand. It's about capturing the essence of words and their relationships in a numerical form. We use powerful models like OpenAI's ADA or sentence transformers for this task. They transform our text chunks into vectors, multi-dimensional representations of meaning. Imagine each word as a star in a vast cosmic web. The closer the stars, the more related their meanings. Vector embeddings create a map of these relationships. Words like economy and employment would be clustered close together, reflecting their semantic proximity. This allows machines to understand that a document discussing economic growth might also contain information about job creation. It's about teaching machines to see the connections, to understand the language of data. We've transformed our text into a format machines can understand. Now we need a place to store these embeddings, a digital repository for our newfound knowledge. This is where vector databases come in. Specialized systems designed for the efficient storage and retrieval of vector embeddings. Think of these databases as vast cosmic archives, each embedding a star carefully catalogued and positioned in a multidimensional space. Pinecone, Weaviate, Face. These are some of the names whispered in hushed tones by those who work with these powerful tools. They are the keepers of our embeddings, enabling us to navigate the vast sea of information with ease. When we pose a question, a query, it's like sending a probe into this archive. The database searches for the nearest neighbors, the embeddings most similar to our query. It's a cosmic dance of similarity where the closest matches rise to the top. This rapid retrieval is crucial for real-time applications. Imagine asking a question about a complex report and receiving an instant answer, the relevant information extracted and presented with pinpoint accuracy. Vector databases make this possible, unlocking the power of instant knowledge discovery. We've built our archive, our repository of knowledge. Now it's time to put it to the test. A user approaches with a question, a query seeking an answer from the depths of our data. How do we ensure the system understands the question and retrieves the right information? First, we translate the user's query into the language of machines, transforming it into a vector embedding using the same model we used for the data. This ensures that the query and the data exist in the same cosmic map, speaking the same language of meaning. Next, the query embedding embarks on a journey through the vector database, searching for its closest neighbors. The database retrieves the embeddings most similar to the query, representing the chunks of text most likely to contain the answer. This is where the true power of AI is unleashed. Large language models, LLMs, our AI assistants, step in. They take the retrieved information and craft a response, a clear and concise answer to the user's question. These models are trained on vast amounts of text data, giving them an impressive grasp of language and context.